In this video, we're going to find the derivative of the function f of x is equal to 1 over 2x plus 1, where x is not equal to minus 1/2. The reason we exclude that value is when x is equal to minus 1/2, the denominator would be 0, so we're putting that restriction on the domain. And we're going to use the definition of the derivative and pay close attention to the algebra that we need to go ahead and do this. So let's remember that the derivative f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. And we're going to go ahead and plug x plus h in and then x in and see what we get. So this is going to be the limit as h goes to 0. Well, what is f of x plus h? Whenever you have a function, the x is just a placeholder. I like to think of it as an empty box, and you drop in there whatever value you have inside the parentheses. So in this case, we have x plus h rather than x. So what does that give us? It gives us 1 over 2 times x plus h plus 1. So let's make sure we understand that. There's the variable. Now we plug this in for x, and so we get 1 over 2 times x plus h. Okay, let's continue. So that's minus 1 over, what do we get here? Just 2x plus 1, and that's all over h. So now we have the job of taking these two fractions and adding them together. So let's go ahead and add that numerator. Here it is, and we see that we have to add these two fractions, 1 over 2 times the quantity x plus h plus 1, and we subtract from that 1 over 2x plus 1. Well, when we add two fractions like this, the first thing we need to do is find a common denominator. We like to find usually the least common denominator. And in this case, the easiest thing to do, in fact, the only thing we can do, is to take the product of those two denominators as our new denominator. So let's do that. So for our new denominator, we get the product, and let's be very careful. Here it is. That's for the first fraction. And the same product, 2 times x plus h plus 1 times 2x plus 1 for the second fraction. And now we have to figure out what goes in the numerators so that each of these fractions is equivalent to the original. There are many different ways to do this. If we look at the first fraction, we see that in order to obtain this denominator, we would have to multiply the denominator here by 2x plus 1. Well, you can't simply multiply a fraction's denominator by something without changing its value. So we would also have to multiply the numerator by 2x plus 1. And so we see that the first fraction is actually equivalent to this one. And if you take a look, you see that these factors would cancel, and we're left with this fraction. We do the same thing over here, but in this case we see we'd have to multiply the denominator by this factor, and so we multiply the numerator by that as well. And of course there's could be parentheses on each of these. But again, we see that if we cancel these factors, we're left with the original fraction. So now we can go ahead and combine these two fractions with the same denominator and see what we get. So there's our denominator, and let's do some simplifying in the numerator. Here we just get 2x plus 1, and here we get minus. Well, let's put in here what we get when we expand. We get, using the distributive law, we get 2x plus 2h plus 1, and of course now we have to multiply that by the minus, and so we get 2x plus 1 minus 2x minus 2h minus 1. And let's see what cancels. The 1's cancel, the 2x's cancel, and so we are left with minus 2h over 2 times the quantity x plus h plus 1 times 2x plus 1. And now we want to go ahead and take this fraction, put it in the numerator in the formula for our derivative, and see how things simplify. Now we're going back to our original definition of the derivative, and we see that we can now replace the numerator by this fraction that we obtained previously, and now we're going to go ahead and see if we can do some simplification. Well, here we're dividing by h, but of course instead of dividing by h, we can go ahead and multiply the numerator by 1 over h. So let's do that. Here we get the limit as h goes to 0, minus 2h over 2 times x plus h plus 1 times 2x plus 1, and now times 1 over h. That's this denominator. Dividing by h is the same as multiplying by 1 over h. Well, we can cancel the h's. Now we let h go to 0, and what happens? Well, this h is going to go to 0. And are there any other h's left? No, there are not. So we get the final answer. We can now take the limit, and we get minus 2, that's all that's left in the numerator, over, here we have 2x plus 1 and 2x plus 1, so we get 2x plus 1 quantity squared, and that is the derivative of our original function. That's all for now. See you in the next video.